When we think of electricity, most of us picture power plants, solar panels, or maybe even wind turbines. But what if I told you there was a way to generate electricity using nothing more than dirt and some metal rods? This method, called an earth battery, is pretty fascinating, and it's not very well known. That could prove invaluable for preppers, homesteaders, and anyone that's interested in trying out cheap electrical power. So what is an earth battery? An earth battery is a simple device that generates electricity by harnessing the natural electrochemical reactions occurring in the soil. It basically involves burying two different types of metal, typically like copper and zinc, in the ground and connecting them with a wire. The soil acts as an electrolyte, creating a flow of electrons between the two metals. This flow of electrons is what we recognize as electricity. Now, while an earth battery is not going to power an entire home, it can provide small amounts of electricity suitable for low power devices like LED lights or charging small rechargeable batteries. By connecting multiple earth batteries together, you can scale up the output to create a trickle charge for emergency needs. So how does it work? The science behind earth batteries is pretty straightforward. When two different metals are placed in contact with an electrolyte, in this case the soil, a chemical reaction occurs. One metal, the anode or anode, whatever, gives up electrons more easily than the other, the cathode. This creates an electrical potential difference or voltage between the two metals. The soil's natural moisture and mineral content help facilitate this reaction. To make the system work, you'll need a copper rod or plate, the cathode, and a zinc rod or galvanized steel nail, the anode or anode, wires to connect the two, and moist soil to serve as the electrolyte. When it's set up correctly, the system generates a small but steady current of electricity. So how do you build your own earth battery? Creating one is surprisingly easy, and it requires very little material. First, choose your metals. Use a copper rod or plate for the cathode and a zinc rod or galvanized steel nail for the other one. The greater the difference in their reactivity, the better the results. Prepare the ground. Find a spot with moist, mineral-rich soil. If the ground is too dry, you can add water to improve the conductivity. Bury the metals. Dig a hole at about 12 inches deep. Place the copper and zinc rods into the hole, ensuring they're at least 6 inches apart to prevent short-circuiting. Then you connect the wires. Attach a wire to each metal rod using clamps or soldering. The copper rod's wire will be the positive terminal, and the zinc rod's wire will be the negative terminal. And test the voltage. Use a machine to check the voltage between the two terminals. You should see a small but measurable voltage. And you can scale it up. If you need more power, you can bury multiple pairs of rods in parallel or series configurations, depending on whether you want to increase your voltage or your current. Using earth batteries for emergency power. While one earth battery generates a very small amount of power, connecting multiple batteries in series or parallel can create enough energy to trickle charge small rechargeable batteries. This stored energy can then be used to power devices like LED lights, small radios, or even emergency beacons. And here's how you can use earth batteries to create a functional power system. First, set up multiple batteries. Arrange several earth batteries in a series to boost your voltage or in parallel to increase your current. Connect them to a rechargeable battery. Use a low voltage charging circuit to feed the energy into a rechargeable battery pack. This helps store the power for later use. Power low consumption devices. Once the rechargeable battery is charged, it can provide consistent power to devices like flashlights, small fans, or USB powered gadgets. This setup is not designed for high power applications, but it can be a lifesaver for maintaining basic functionality in an emergency. The historical use of earth batteries. This is not a new concept. They date back to the 19th century when people like Alexander Bain and Thomas Edison experimented with them as a way to power telegraphs and other devices. In fact, Bain's early designs were used to send signals over long distances, making earth batteries an essential part of early communication technology. Practical applications today would include earth batteries may seem outdated, but they have significant potential in specific scenarios. Emergency preparedness, when other power sources fail or you don't have any other, an earth battery system can trickle charge small batteries to keep essential low-power devices running. And in off-grid living, earth batteries offer a sustainable way to generate some power without relying on external resources. So what are the limitations of these things? While earth batteries are an intriguing option, they definitely have limitations. There's a low power output. Earth batteries produce small amounts of electricity, typically in the millivolt to low volt range. They're dependent on the soil quality. The efficiency of an earth battery depends heavily on the soil's moisture and mineral content. Corrosion over time. The metals used in the battery will corrode and need to be replaced periodically. But recent advancements have actually improved the efficiency of earth batteries. Researchers are exploring ways to enhance their power output using specialized electrolytes, advanced materials, and better configurations. You never know, these innovations could make earth batteries a more practical solution for small-scale energy needs. They may not replace your solar panels or your generators, but in a pinch, they could provide enough power to make a difference.